Welcome to COM 2026 OOP. Today we're going to talk about the Java operators. Java has a lot of operators. These operators help you to mix those variables, values, strings together and make it become more useful. We'll go through each of these operators one by one. The first one we want to go through is the arithmetic operators. You must have seen these things before, like parentheses, negation, multiplication, divisions, and so on. Okay, now let's talk about the parentheses. Parentheses will make the number calculate first. In your primary school, secondary school, maybe you have used other bracket symbols, like the square bracket, the bracelet bracket as parentheses. But in Java, the only parentheses that we can use in arithmetic will be this one. Okay, so the other one I want to talk about is the multiplication symbol. Now, in mathematics, perhaps you can write 4 parentheses 2. That will be meaning 4 times 2. But in Java, if you want to do 4 times 2, you must write 4 asterisk 2. Now, this asterisk symbol will be shift 8. Okay, division. If both operands, meaning the divisors and the dividends, are all integers, that we're doing integral divisions. But if one of these are decimal numbers, that we're doing decimal division, such as the example here and here. This percent symbol means modest arithmetics, which means finding the remainder, basically finding remainders. So 47 divided by 4, what we call 47 mod 4, is actually equals to find the remainder of these expressions, okay? And that is 3. It will be nice if we can keep a space between the operators and your operands, except for the parentheses. Okay, so for example, this one, we should write this way. Now, this is not mandatory, but it's a good habit we should keep. So now, these are some examples that you want to look at. So for example, this one, after a few parentheses, it will still give the same value. This one, 7 mod 5 will give you 2. Okay, 9 divided by 2 will give you 4. Why is that? Because we mentioned 9 divided by 2, both of them are integers, so this is an integral divisions. That will give you a 2. That will give you a 4. Now, this one, 9 divided by 2 times 2, so this one therefore will be 4 times 2, which is equals to 8. Okay, don't try to cancel out these 2 divided by 2 and times 2. No, it can't be cancelled out. This one, if number 1 is variable and plus itself will actually evaluate to twice values of number 1. This one is invalid, as mentioned. That's the reason that I've just mentioned. This one will give you an error. Why? Because 99 divided by 100 will go first, and this gives you 0. 2 divided by 0 will give you an error. This error, okay, will stop the program. Neither 2 arrow 3 or 2 star star 3 would mean 2 to the power 3. None of them will mean that one. Okay, so if you want to calculate 2 to the power 3, probably you will actually need to write a loop to do it or use the math API. In Java, none of these will give you the answer 8. Assignment operator, which is an equal symbol. Okay, in mathematics, equal symbol basically saying that the left side equals to the right side. But in programming language, this operator actually is telling us to put the things on your right hand side to your left hand side. So your left hand side must be one single variable. You can't put, let's say, 5 plus 10 on your left or A plus B on your left. No, you can't do it. You can only put a single variable on your left, which in this case, regardless what's the original values of A, that will give you 15 into A. Now, sometimes we might want to write something like A equals to A plus B, A equals to A minus B, etc., etc., right? Now, here, if you want to do something very similar to this one, you can do A plus equals B, A minus equals C, which has the equivalency of doing things at this point. This is a shorthand inherited from C and C++, which is very useful sometimes. Next, we want to talk about the post-increment and pre-increment, post-decrement and pre-decrement. So the symbol plus plus we call the increment. The symbol minus minus we call it the decrement symbols. Post-increment will be this plus plus symbol followed after a variable. Let's say I plus plus, that is post-increment. This means I equals I plus 1. Similarly, if you do I minus minus, it means I equals to I minus 1. These plus plus and minus minus symbol can also be placed in front of a variable. And if you do that, we will call this a pre-increment or pre-decrement. Okay? So plus plus I will also mean I equals to I plus 1. Minus minus I will also mean I equals to I minus 1. What are the difference between these two? Now, basically, is the value that returned from these expressions will be slightly different. Both of them will do plus 1 or minus 1, but in pre-increment, the change of the value will happen first. We will add the value by 1 first and then use the value. In post-decrement, we will use the old value and then add the value by 1. Now, what does that mean by use the value? Let's take a look at the example below. So in pre-increment, let's say I equals to 10. J equals to I plus plus I. Now, what does that mean in this line? This means we need to add the value by 1 on I first. So I will become 11. And then J will take the new value of I. So I and J will both equals to 11. How about post-increment, which is this case? So I will equals to 10. Now, because this is post-increment, so J will take the old values of I, which is 10. So J equals to 10. And then the value of I will be increased by 1. So I equals to 11. Okay. Now, how about this one? This pre-decrement and post-decrement work very similar to the increment. If I equals to 10 and we have minus minus I, this minus minus will operate first and then take a new value of I, assign it to J. So that will give us I equals to 9 first and then J equals to 9. Post-decrement, in this case, we will assign the old value of I, which is 10, to J, and then followed by decrease the value of I by 1, which is 9. So what does these things mean? In particular, this one, A plus 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 B. Now, we can understand this line by two different ways. Either by A plus 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 B, or A plus plus and then plus B. Which one should we go? Now, in fact, post-increment or decrement should have a higher precedence, which means in this particular example, we will treat A plus plus as a token, okay, and then plus B. So what will happen is A plus plus will operate later. We will take the old value of A first, which is 5, plus B, which is 4. And bringing them together, we got C equals to 9. And the value of A will be changed to 6 later. As a good practice, post-increment or decrement is useful and theoretically running faster than I equals to I plus 1. And also, I plus plus will look a little bit nicer, okay, than this line. So you can try to use I plus plus or plus plus I whenever you feel possible. And there is some reminder that you shouldn't increase more than one post or pre-increment in same line to create ambiguity. And also, we should not cascade our assignment operators except for equal sign. Now, so take a look at this example. A equals to int a, b, c. Now, this line will make sense where the every symbol on the left on the equal sign is a variable. Okay, so they can all be placed on the left-hand side of the variable, and each of them will have the value of 10. Okay, this is rather easy to understand. But this one, the second line, will be a little bit problem. Okay, this one will give you some very unexpected result. We don't encourage students to do it. Now, because we discourage you to do it, so we won't ask question like this one the third line here in our quiz. Also, for the last one, if you have um, uh, assignment operators with the value b here, that could create some problem. You're not really sure when this b is happening, b is happening, and when this b will be assigned. Okay, so try to not do these things and try to make your program simple. Relational operator is the next operator we want to talk about. Now this one is unlike the assignment operator. Assignment operator, we want to assign values on your right hand side to your left hand side. But here, what we want you to do is actually to compare two variables, A and B, and see whether they have the same result or larger than the other one. The values of these relational operators will either be true or false. Now, so it depends on the values of A and B, which could be a variable, could be a number, could also be an expression. Okay, let's say the things on your left hand side is larger than the things on your right hand side. This one will give you true. Okay, similarly, this one, if the things on your left hand side is greater than or equal to the things on your right hand side, that will give you true. Otherwise, it will give you false. Okay. Now, if you want to check if two expressions give you the same value, you can use equals equals. So let's say A equals to B, which means we're asking whether the value of A equals to B. That in this case, if they're the same, you will give a true. So the last one here with exclamation mark equal sign will means that whether these two are not equal to each other. Okay. Now, these relational operators are extremely useful when we use it with if conditions, if else, loopings. Okay. So we will see these things a little bit later. The next one is logical operators. Now, to combine different logic, true and false, we will use these logical operators. Namely, AND, we call this AND, and we call this OR. Okay? The AND operators has two ampersand symbol, and the OR operators has two pipe symbol. Okay? So what does that mean? If B1 and B2 in this example, if these two variables, expressions, values are both true, now this operator joining these two together will give you a true value. Now, if one of these is false, so for example, we say B1 is false, B2 is true. Now, these things combined together will give you a false value. Okay, if both of them are false, then B1 and B2 will give you false. The second one, OR operator. Now, if either B1 or B2 is true, okay, or both of them are true, then we will say the values here is true. Okay. The last one, not. This is a not operator. Exclamation mark means not. Okay. Not B1, which means if B1 is true, that will give you a false. If B1 is false, that will give you a true. Now, so look at the truth table below. Assume we have different values or combinations of B1 and B2. B1 can be true, true, false, false, and B2 can be true, false, true, false. So all these four different combinations, we have different values produced by B1 and B2, B1 or B2 or not B1. Okay, so can refer to this table to understand what is true, what is that this and not or meaning to you. Okay. Now, if you still remember the expression we have just explaining, B1 and B2 relies on both variables to be true. If we already know B1 is false, what will happen is we don't need to check B2 anymore, because no matter B2 is true or false, as long as B1 is false, the entire expression will be false anyway. In this case, the Java language will skip the evaluation of B2. Okay, so B2 will not be evaluated. As this one we call a short circuit, because B2 will be short and it will not be executed. In all operation, as long as B1 is true, no matter what the values of B2 is, the whole expression will give you true anyway. In this case, we don't evaluate the value B2 if B1 is true. And that is another short circuit. Now, what does this short circuit means in our programming language? So take a look at this example. Assume Boolean 1 equals to this expression. Okay, now try to understand that bool1, bool2, and bool3, what are their values? Okay, as an example. The first one, bool1 equals to 3 equals to 2, or 2 smaller than 3. The expression here will be false. The expression here will be true. Now, false and true will give you a false. The second one, bool1, because this is false, not bool1, where it equals to true. True or this one will be false. True or false will give you true. The last one, bool1 will be false. Bool2 will be true. So, and these two terms together will give you false. Not false will give you true. So bool3 will also be true. Now, I hope this one will be easier. And this is nothing related to short circuit yet. These will be something related. Now, first of all, we have to understand if we ever conduct 1 divided by 0, it will give you an error. Okay? So imagine this line is not executed. And let's see B1, B2, B3, B4. The evaluation of each of them, which one will give you an error. The first one, this one. 3 equals to 2. Is this true or false? Well, this one is false. Now, because this one is false, so by short circuit, the later part here, no matter if it's true or false, it will be giving the entire expression as false. So this part will not be evaluated and will be just skipped. Okay, so B1 will actually use the false. How about B2? B2, this part will be true. Okay, and so the second part will need to be evaluated. So B2 will give you an error. B3, this part is false. Okay, and so false or the other one, the second part will be important. So this part will be evaluated, and that will give you an error. The last one, 2 equals to 2. Yes, this one is true. So the rest does not really need to be evaluated. and that is another short circuit. So B4 will give you true. Okay. Now, so next one we want to talk about the arithmetic operators for char. Char is stored using Unicode internally, which is also a number. Okay. We can perform plus or minus over character with some restrictions. Now, so for instance, if you have a character num here, and we calculate int a equals to num minus 0. Now, what would that mean? Now, because num is a character of the symbol 8, which has a Unicode value of 56, minus 0, and this 0 is also taking a Unicode value of 48. So effectively, this one is computing 56 minus 48, which will give you 8. So a will equals to 8 in this example, where a is an integer. Okay? Now don't be confused, this num has the values of the character a, which use the Unicode value of 56. So effectively, num is stored internally with 56, where a is stored internally with the value 8. Okay? We can also use larger than or smaller than, which is the relational operators in for char characters. So for instance, input larger than a and then input smaller than z. Now in this case, it is actually referred to if a is one of the values of b, c, d, e, f, g up to w, x, y. Okay, if one of these, then this input will have the RST value lying between small a to small z. Okay, so we can say that, oh, the input is lowercase. Of course, if input is a, okay, this expression would not be whole, and so the entire expression will not be whole too. We can also use a plus symbol over strings to combine two strings. Okay, for strings, we can use plus symbol. We don't use minus. Okay, remember strings are really related about what? String is about multiple numbers of characters. And this plus symbol means concatenations. Okay, joining those together. So let's say string equals to A, B, C equals to respective values. D equals to A plus a space plus B plus C will effectively equals to these strings. A string can also be combined with an integer as well. So for instance, this D will give you what? A, B, C, 1, 0. Okay, 5 characters strings into D. Now, to compare a string against another strings, please don't use the relational operators double equals. Okay? If you use single equal, it does not work because that means, what does that mean? That means the assignment operators. Assign things on your right hand side to your left hand side. It never works. If you use double equal sign, okay, this also does not work. A correct way to compare strings will be using the string dot equals symbols. Okay, so s1 dot equals ABC. Now this one will work. The next one we want to talk about are bitwise operators. Bitwise operators are less common than the other operators that we have just seen. These bitwise operators are operate on bit levels. So assume that we are operating with numbers. Actually, this is always related to numbers only, okay, in particular integers. Of course, you can operate these to some other special types as well, but mainly we are operating on bytes, shorts, int only. Now look at this one. Assume a equals to 0b0010. Okay, B will 0B, 0, 1, 1, 0. What does that mean? With a number signed with 0B, that means this in a binary format. So in this case, A will equals to the values 2, okay, because the second bit is 1, so there will be 2 to the power 1, so this is 2. Well, B will be 0, 1, 1, 0, which has the decimal value of 6. Okay, and we can definitely say A equals to 2, B equals to 6. That will be exactly the same. But for illustration purpose, we just express them into a binary format so that we will be easier to understand in this operator. Okay, and also we assume A and B are byte. Okay, so there are only 4 a byte, so there are 8 bits with this value A and B. Okay, now the first one is bitwise complement operators. Okay, bitwise complement. So A, if you take the inverse of this A, was actually inverting every symbols in this variable. Okay, so effectively you change every 0 to 1, 1 to 0. For B, okay, for the second one, A or B, that's actually doing bitwise OR operations. Okay, what does that mean by bitwise OR operation? So for each of the bits, if both of them are 0, okay, we will treat it as 0. If either one of them is a 1, then we'll treat it as a 1. Okay, so if you look at the result here, A or B, okay, remember in this bitwise operator, we only use one pipe symbol. Okay, A or B, that will 0 and 0 mixing together because both of them will be 0, so it gives you a 0 here. 0 or 1. So the second bit, because it's 0, and second bit of B is 1, that will give you a 1. The third one, 1 or 1, that will give you a 1. And the last one, 0 or 0, that will give you 0. So A or B will give you 0, 1, 1, 0. And A and B will do exactly the same thing, except that we need both of them, both bit are 1. Okay? And then give you a 1. Otherwise, we will just 0. So the only bit that both of them are 1 will be the third bit. So that will give you 0, 0, 1, 0 as a result. This little pointy arrow, we have just seen that a few pages before. This actually is an exclusive OR operator. Now, what does that mean? This exclusive OR operator means that it's asking whether the bits are different. If the bits are different, we have a 1. If the bits are the same, we have 0. Okay? Now, this one we call XOR. Okay, we read it as XOR. So let's say A XOR B. Okay, what will happen is we read the symbol 0 XOR 0, that gives you 0. 0 XOR 1, that gives you a 1, because they're different. 1 XOR 1, that gives you 0. 0 XOR 0, they're the same, so that's also give you 0. So this one will give you 0, 1, 0, 0. And then these two will be the shift operator. Basically, this one means that you multiply that by 2 to the power n, okay? That one will be shifting rightward divided by 2 to the power n. So effectively, A shifted to your left by 2 bits will give you, which means shifting this entire string 2 blocks to your left. So this one will going to 1 bit and 2 bit, so that will become 1, 0, 0, 0. Okay, when the 1, 0 moving to here, we add some 0 from the tail. Okay, and how about this one? This one will be shifting the things to your right. Okay, so B right arrow 2, that will give you 0, 0, 0, 1. Okay, and we fill up 0 from the top. The next one will be bitwise operators. Example, Now, the following program is very interesting. Okay, we're trying to understand that how these, as example, we can see, could be a little bit tricky. Now, let's try to follow me. This program try to check whether the value A, B, C, D, all of them contain the value 1, 2, 3, 4 in any particular order, in any order. Okay, so assume that A, B, C, D have their value assigned it, and let's try to do these things. Result 1 equals to 1, and then left shift A. Okay. Now, what does that mean? That means that I'm going to shift 1 by the amount of A, okay, number of bits. And assume A, B, C, D take the values from 0 to A. Okay, so effectively this is multiplied 2 to the power A. Okay, 2 to the power A. Okay. Now, so assume if the value of A is 4, so effectively this one left shift A will has the values here. This is the expressions. Okay, so shifted by 4. So originally we have 1, and then shift it to 4 to your left. That will become 1 0 0 0 0. Okay, which means append 4 0 after the 1. Okay, so this has the value of 16 in the result. The second one, 1 left shift B. Now B takes the value of 3, which append 3 0 after that one. Okay, so that will be 0 B 0 1 0 0 0. Okay, so effectively we have this number. The result of the values of result will be equal to 16 plus 8. Okay, similarly, C equals to 1, so we put 1 0 after 1, that will be 1 0. Okay, and then we XOR with the result. Okay, XOR with the result, so this value XOR this value. Okay, and which means actually we are taking the difference. Okay, 1 1 we'll put it in the top, and then this one we'll put it in here, so we have here. Okay, the last one D will equals to 100. Okay, 100. Okay, not 100, 100. Okay, this one, and this one XOR with this one will give us 11110. Okay, now either one of these values are not, if some of the values here are repeated, or some of the values here has the range outside 1 to 4. So let's say D equals to 5. Then the result here is 1, 2, 3, 4 will have the value of false. Only if these four values take different distinct values of 1, 2, 3, 4, then the result will equal to 16 plus 8 plus 4 plus 2. Okay, otherwise they won't be the same. The next one is conditional operators. Conditional operators works like the if function in Excel. I'm not sure whether how good are you in using Excel, but in Excel we do have this if function, which is very, very useful. Okay, now the condition will be evaluated as true or false. Usually we will have a relational operators in this part, and then we will have a question mark followed by a value and a colon followed by another value. Now what does that mean? That means if the condition is true, we will take the values of A. Otherwise, we will take the values of B. Now, because this condition could be either true or false, so the entire expression here will give you the value either A or B. Now, take a look at this example. Let's say fan speed equals to something, equals to the expression on your right. This is a conditional operator. Now, if this value here is true, we will take the value of 50. If the values here is false, we will take the value of 20. Okay, so the value of fan speed will be either 50 or 20. depends on the values of the temperature. Similarly, let's say gray equals to mark smaller than 35, question mark F, colon P. What does that mean? That means the gray will equals to F or P, depends on the values of mark. If mark is less than 35, then we have F. We can also cascade the conditional operators. Okay, so let's say this expression, wow, it looks so complicated, but you can actually divide these things into several parts to make it easier to understand. So read it from your left, mark more than 80. Now, if this condition is truly fulfilled, we'll take the values of A. I think we don't have any problem, right? Now, if this condition is not true, then we will need to look at the value produced here. Now, what's the value produced here? That really depends on the values of mark if it is larger than 70. Okay? If the mark is larger than 70, that could be a B. All right? Now, you may wondering, hey, what if the mark is more than 80 then? If mark is more than 80, would that be still a B? But I think it should be an A. Now, if the mark is more than 80, it was already returning the values A here. Whenever you come to this colon sign, means the condition is not fulfilled. So the mark is not more than 80 in this case. And if the mark is not more than 80, but is also more than 70, the value must be B. Okay? And then if it's not more than 70, we're going to ask whether it's more than 40, okay, which is 40 to 69, then we will get a C. Otherwise, we'll get an F. Okay? Now, when will you use these conditional operators, especially when you need the values that assign it to our variables, or you don't bother to write if else statement, you think it is too complicated, then you can use conditional operators, which will shorten your code a little bit. Okay? And the next thing I want to talk about is the operator precedence, which means which operator will go first. Now, apparently, we will know that multiplication symbol will go higher than plus or minus symbols, right? In mathematics, we do that. In programming, we also do that. Okay, and whenever there is a parenthesis, we will evaluate things in parentheses first. So remember the following rules: always evaluate things in the parentheses first, or the bracket first. Okay, and then we're going to evaluate that. Then we will take the I plus plus or I minus minus, which is the post-increment or post-decrement first. And then we will evaluate the pre-increment, pre-decrement, followed by the multiplication and division, and the addition and subtractions. We will always evaluate the expression from the left to your right if they have the same precedence. Okay? And the logical operators, and is always higher than all operators. So this is the operator precedence. Okay, I plus plus has a higher precedence than plus plus I. Okay, multiplication has a higher precedence than this plus symbol. Okay, this shift operator has a higher precedence than the others. All right. So now let's try to understand these operator precedence and also the function of these operators as a summary. So first one, 2 will give you a 2. Okay, it does not do anything. So this will evaluate the value of 2. 2 times 3 will give you a 6. This one, because we need to do the multiplication first. So 4 times 3 equals 12 plus 2 is 14, and then minus 7 will give you 7. Okay, and how about this one? Okay, we will evaluate things inside the parentheses first. So 2 plus 3 equals to 5. 11 divided by 12 which is an integral divisions, give you 0. So this one is 0. Okay. And this one, number 8, 1 plus 0 mod 9. 0 mod 9 will give you 0 because it's actually calculating the value of 0 divided by 9 and find the remainder. So this is 0. 1 plus 0 will give you 1. Okay. So on. So today we have gone through all the arithmetic operators, assignment operators, relational operators, logical operators, bitwise operators, and the conditional operators. I hope you have some very basic concepts about these operators. And I shall see you next time. Goodbye.